Alright, so this time is 4.2, and we're learning to solve quadratic equations by graphing. So, when you're solving quadratics, this basically means you're trying to find out where the quadratic crosses the x-axis. Okay? So, here we're going to be graphing equations to find the solutions. Now you can use Desmos or graphing calculator, whichever one you have more easable access to. Okay, so first example says that we're looking to solve a quadratic equation that has two real solutions. Okay, so we have x squared plus 2x equals 3. Now the thing is, we want to make sure to set that the equation needs to equal 0. Or in other words, y needs to be 0. And this is because on a graph, if you're trying to find the x-intercepts, you're trying to find the value of x when y is equal to 0, or the x-intercepts. Okay? So y needs to be 0. Or one side of the equation needs to be 0. So that means here we have to subtract the 3 from both sides. So we have x squared plus 2x, but now we subtract 3 and it's equal to 0. So that's the first thing you have to do. So first, make one side equation equal to 0. Okay? And when you have that, just graph it. So I actually have that right here in Desmos. So x squared plus 2x minus 3. So in Desmos, it's really nice because it actually tells you, if you can click on the points, it tells you where the graph crosses the x-axis. So you see that where y is 0, you see that the y in both points, the y coordinate is 0. And then the x, we have negative 3 and 1. Okay, so we know that x is equal to negative 3 and x is equal to 1. Negative 3 and 1. So these are solutions. So we just solved this quadratic equation and we had two solutions because it crossed the x-axis twice. So let's look at this one right here. In example 2, solving a quadratic. This time it should only have one solution. We'll see what that looks like. But again, we need to make sure that one side of the equation is equal to 0. So we have this negative 16 over here, and I don't want that over there, so I'm going to add 16 to both sides. So I get x squared minus 8x plus 16 equal to 0. So when I have that, let's graph it here. Okay, so you see that it only just touches the x-axis right there. So there's only one solution, and that solution is x is equal to 4. There you go. So only one solution there. Now looking at this one, so we're going to actually solve this in two different ways. So this one says that it should have no real solution. So let's see what that one looks like. So we want one side of the equation to be equal to 0. What I'm going to do is I'm going to add an x squared to both sides so that my x squared is positive. So that means this side will be 0, and if I add an x squared over here, I get x squared plus 2x plus 4. So actually, I'm going to change this right here. So this will be plus, and this will be plus. There we go. Okay, so here you can tell that we have a vertex and we have a y-intercept, but the graph does not cross the x-axis. So if the graph doesn't cross the x-axis, we say that this has no real solutions. So no real solutions. And that's pretty much it to this one. So basically, a quadratic graph can have 2, 1, or no real solutions. It has 2 if if you have 2 locations of crossing the x-axis. You can have 1 real solution. This means that the graph only touches the x-axis, and then no real solution means it doesn't touch at all. So it doesn't touch x-axis. Okay, that's pretty much it for that one right there. Okay, now let's look at this one right here. This one is approximating. So this example, we're trying to approximate where the 0 is at. So we have a graph of x squared plus 4x plus 1, and that's shown right here. And it wants us to approximate to the nearest tenth. Okay, so we see here that we have a 0 between 4 and 3, negative 4 and negative 3, and between 0 and negative 1. So we don't know exactly where it is. But here we have these tables, so again we know that this one is between negative 3 and negative, so right here would be negative 4, here would be negative 3, so we have values between them, and then over here this 0 is between negative 1 and 0, so this would be 0 and this would be negative 1, and these are all values in between them. To the 10th, right? We're counting by tenths. So can we figure out where it crosses? So we have to look for a sign. When do we know when it crosses? So what we're going to do is we're going to take the equation x squared plus 4x plus 1, and we're going to plug these values into the equation and see if we can figure out where the 0 is at. Okay, so let's see here. So let's take negative 3.9 and plug that into the equation. So negative 3.9, I'm going to plug that into an equation of x squared plus 4x plus 1. So this is equal to 0.61. Remember that this value is 0, right? This value is 0. We're trying to find the value of 0. Seeing if we can find one close to 0. If this is going to be a solution, then that means the y must be 0. Okay, so let's try negative 3.8 then. Okay, so whenever I plug that in, let's see if I get x, oh, 1 second. So if I do x squared plus 4x, so x squared plus 4x plus 1, I get 0.24. Okay, so I'm getting closer to 0. Now let's try negative 3.7. So let's do x squared plus 4x plus 1, and that's equal to negative 0.11. Okay, let's do one more, negative 3.6. Okay, let's do x squared plus 4x plus 1. When I plug that into a calculator, I get negative 0.44. Okay, so we're not getting any zeros, but what you might notice here is that here both of these are positive values, but here we get negative values. So what that tells me is that when we are at negative 3.8 on the x, we're positive, meaning we're above the x-axis, but then whenever I plug in negative 3.7, I'm below. So if at one value I'm above and one value I'm below, that means that my x-intercept is somewhere between these points. So my solution is somewhere in between negative 3.8 and negative 3.7. So my solution is somewhere between here. Okay? So basically I can approximate the solution here to be, I know that x is equivalent to about negative 3.7. That's an approximation. It's not for sure, but it's pretty close. Now can we do the same thing on this side over here? Can we plug in some values? So let's go ahead and try some values. So I'm going to just start, I'm just going to start guessing. Let's try negative 0.07. So remember that over here that we just went negative, so sometime we're going to have to go positive. So I'm looking at a switch between negative, from negative to positive. I'm looking for a switch between negative to positive. So I'm going to try plugging in negative 0.7. So if I plug in negative 0.7, I get negative 1.31. So we're still negative. Okay, let's try negative 0.6. When I plug that into x, I get negative 1.04. So still not getting that close. I'm going to try and jump to negative 0.4. So I'm going to try plugging negative 0.4 into the equation. So I plug that in, I get negative 0.44, so I'm getting close. Now let's try negative 0.3. Here I get negative 0.11. Now let's try plugging in negative 0.2. So negative 0.2, I'm going to plug that into my equation. Here I get 0.24. So you can see here I went from a negative to a positive number. So what that means, again, my values here are going from negative to positive. So that means somewhere in between them is my x-axis, is my solution. So my solution is somewhere between these numbers. So let's approximate it. I'm going to take negative 0.3 since negative 0.11 is closer to 0 than here. So that means my solution will also be negative 0.3. So there you go. That's how you can approximate solutions. Okay. So that's pretty much all it is for this 4.2. Basically, it's just using graphs to help you find solutions. So in the last unit, you might remember we used we would factor. Factoring's a way to find solutions. We'll find other methods of finding solutions to quadratic equations, but graphing is also a way to find solutions, and that's just the focus of 4.2. Alright, so that should be everything. Let me know if you have any questions. You can send me an email, or I'll see you in class.